Hello everyone and welcome back. Today we have another episode of the Threat Modeling series of the Cybersecurity and Cloud podcast. And I'm so honored to have Adam Shostack on the show. Adam is the creator effectively of threat modeling as we know it today. He's been working in Microsoft. He is one of the people behind the threat modeling designed for security, main author, Black Hat speaker, and in the board of reviews. He's been working on threat modeling since the very beginning, and we explore some deep topics about not just threat modeling, but cybersecurity and how it evolved from the very beginning of the days from C and traditional language and how it changed today. And we can explore effectively the importance of threat modeling and the importance of open sourcing and working smart, not harder. Adam is currently teaching threat modeling, and please go and check his link, his books, and most importantly, enjoy.
Welcome to the Cybersecurity and Cloud podcast, where we hear the stories of information security professionals. This podcast explores different angles, out-of-the-box ideas, and the human element of cybersecurity. If you enjoyed today's episode, please consider leaving us a review on Apple Podcast and supporting us at www.patreon.com/CSCP so we can continue to bring on amazing guests. You can watch videos of the interviews at www.cybercloudpodcast.com.
So hello everyone and welcome back to the Cybersecurity and Cloud podcast. Today we have the absolute pleasure and honor to have one of my reference figure from Black Hat onwards in the show. And I had to tell you, Adam, I felt really shy to ask you to come in and to share your knowledge about threat modeling. And then we had some chat here and there, but it's an absolute honor to have you on the show, and I'll let you introduce better than I can on whatever you achieved and done for the community. So Adam Shostack on the show. It's an absolute pleasure to have you. Welcome.
Well, thank you for your kind words. And, I think like many of us, I am just trying to make things a little bit better than I found them. And along the way, I've had the opportunity to do so in some high impact ways, including helping create the CVE, joining the review board for Black Hat, a book on threat modeling that people like, software and a couple of games to help people threat model. And so, I do appreciate the kind words. And I was talking with someone recently about what's it like to join the industry. And I said, I don't really know what it's like, because when I got started, there literally wasn't a CISSP. There was a single degree program. And so, I'm in this sense very lucky, because when I joined, the competition to do useful things was a lot lower.
But also harder.
Yeah.
But no, it's an absolute honor. It's an absolute honor and pleasure to have you on the show. And yeah, no, you bring an interesting point. I don't know if you come across Ray Redactor, Ray William, and we were actually discussing this about who started some years ago when there was no formal introduction on cybersecurity, and now we have mentorship, we have a lot of information available, a lot of structure, and a lot of people that dedicate, like you, like myself, time to the industry to say, this is how you should start, or this is how we learn. But in our time, it wasn't really available. It was, you were doing just computer science, and then you were learning in the way.
Yeah.
How did you actually stumble across cybersecurity? How did you start?
So my first job was at a hospital research lab, and the work that we were doing, they still are doing, was to gather data from things like CT and MRI machines and use that for surgical planning. And so we were dealing with real human patients in situations where we were doing experimental surgery with computers. And so security mattered. And my boss was fantastic at giving me the time and opportunity to start learning about security and to find mentors and to really investigate. And over time, I discovered that was the piece of my job that I enjoyed the most, and ended up moving from that lab to being a consultant. And that was in the mid 90s. I did work for a variety of folks. I actually did secure coding work back then with a large bank, helping them get on the internet, in fact, and allow people to start doing stock trading on the internet.
Back in the days when internet was for the cool kids.
Yeah. And so, if we're going to do origin story, I found some vulnerabilities in things and went from there to a startup that was working on what we now call a vuln scanner. I don't think we had that terminology quite at the time. And the CVE came out of the fact that we were trying to figure out what a vulnerability was. What do we put a check in the scanner for? So you think about your Qualys or your Tenable, and you think about that without the CVE there to help say, this vulnerability listed on this website is the same as this vuln listed on this other website, or they're distinct.
How do you make the difference?
Yeah. Figuring out what the difference between the two descriptions was this enormous challenge at the time. And so there's this real business problem that we had to go after. And when I met Steve and Dave at the workshop on vulnerability databases, I said, holy cow, this could solve so many problems for us. And so, yeah, that sort of opportunity to solve that sort of problem is something that I think we all have to be on the lookout for, to say, is the work that I'm doing urgent or is the work that I'm doing important? And it's very easy. It's very easy to focus in on the urgent, the immediate, the thing that's getting the chatter, and lose sight of strategy. And one of the things that I think is important about application security is that it gives us a chance to step back from the immediate stream of vulnerabilities and say, how do we actually address the systemic problems that get these vulnerabilities into our products, into our systems, into the services we offer?
So it's interesting. Is a very interesting thing, because I absolutely can't agree more about the strategy and about how important is a holistic view of application security, not just firefighting. Otherwise, we will continue to do bug bounty and firefighting, but we will never win the war. We will never get ahead of the cart. We will always be, what's the immediate problem, what's the immediate fire to fix? And it will be enormously stressful, as it is in operation sometimes, but we will never get better.
Yeah.
And I really had the chance and opportunity to do some amazing application security work, and I saw the real benefit, not just on the company, but on people's life, on the developer that felt I have a story where I saw the relief on people when we said, well, there is this fantastic OS library that you can use to do, parsing or to do input validation, and you don't need to reinvent regex. And nobody loves regex. Who loves to just write? Well, I had some friends that actually had some mental issues and love regex, but that's a different story. But aside from a very small part of the population, I think very few people like to do boring stuff or non-creative stuff or very complex stuff, people want to go on with their life, especially from the development world. And if you can give that bit that you can see, because you have the vision as a security expert, you have you or whoever is doing an application security program has that broad view and broad vision, it makes their life so much easier, don't you think?
Yeah, and it's really interesting because one of the things you're bringing up is the satisfaction that people get from their work or the discomfort that they get. So if I flip it around, one of the challenges that security has is this idea that you're never done, that there's always another threat.
Yeah.
And talk about a way to make people dissatisfied with their lives. You're not good enough. You haven't done enough. Oh, you did more? That's nice. But look at this clever thing I can do to just undo all of your work.
And break every part of your code.
And on the one hand, we've got a real need to do this. And at the same time, we've got a real need to support the teams that we're working with, the businesses that we're working with, and give them the opportunity to say, I have done a reasonable job here. It's not that no one can ever be clever and bypass it. It's that when they do, when I look at like the Spectre and Meltdown attacks, those are really remarkably clever. And it's like, that's good. That's nice work. When I look at the latest remote file include or the latest SQL injection attack, I say, wow,
again.
Why don't we have, and so we can give people prepared statements. We can use static analysis to find the remote file inclusions. We can get better. And I think there's a real value to saying this attack deserves respect. And you as developers, I'm totally okay that you've missed this one. Whereas the remote file include, the SQL injection, nope, actually in 2020, I expect you to find those.
Buffer overflow, input validation.
I will let me be old. Let me be old for a moment.
I'm sorry you have gray hair, so I can relate.
I remember when LF1 released his paper on smashing the stack for fun and profit and starting to find buffer overflows in C code. And I wrote some really dumb grep statements to help us find them, and we found an awful lot of them. And I looked at the scale of the organization I was in, and I said, wow, we're never going to overcome this. I remember how depressed I was. And over the last 20 years, between better and better static analyzers, between things like ASLR and StackGuard and other technique, better library calls like stir-lcat or safestir, data from Microsoft, and this is going back 5-6 years now, work that Matt Miller has done, buffer overflows are largely gone from Windows. That's a stunning engineering achievement.
And that's actually remarkable, even though we still see that in Code Analyzer, and few of the people that I work with, client that I had, buffer overflow was still the majority of things, Java, non-Java. And that might be taking the tools with a pinch of salt. So whatever the tool says, go and have a passover, because you might have a framework, as you say, you might have a library that might not be actually vulnerable for those things. And it could be a false positive or a true positive, but it's, as I always say, take the tool as a tool. Don't be used by the tool. Don't become a tool.
Yeah, the tool does not have your best interests at heart.
No. And definitely not the vendor, because they want to keep on vending. Oh, and by the way, whatever we're going to say is absolutely our opinion. It doesn't represent client and so on and so forth. So please don't sue us. I always find myself saying something very, very clever that is
could be using code against me in so many ways.
You
So I'd rather
know,
say that.
I do expert witness work, and
Okay,
the,
that's interesting.
the thing I have learned in doing expert witness work is I now understand why lawyers don't write things down.
Oof.
If someone wants to sue you, it doesn't matter whether or not you have done anything wrong. They can sue you, and they can spend a lot of your money. And fortunately, I'm working a set of cases where I think people really have done wrong things, but worrying about could someone sue me over these words, the answer is just yes. Yes, they can.
Even with the statement.
Yeah, just say what you want to say. Be good to one another. Be generous. Be fair, and you'll do okay.
And I don't think I'm important enough to matter anyway, even if I say something extremely damaging. But I do believe, circling back, I do believe that static code analysis have done an amazing work, and framework as well. So we were talking with Tanya, I don't remember when this podcast will come out in a sequence, but we were actually talking about this with Tanya on a number of frameworks that has completely eradicated certain problems like cross-site request forgery, or well, we still have cookies and identity being stolen because of tracing cookie, but that's just bad practice that gets taken over and over that we can still eradicate with education. But framework, on the other hand, new language have completely eradicated a whole generation of things. And I was having this debate with the developers. Should we invest more in static code analysis and doing education? Or should we just say, let's move to a different framework altogether? But you don't have always the leisure to do that in an organization and say, well, let's forget that we have COBOL and that we have mainframe and let's just move to Go.
I think that for and look, 99% of work is not greenfield. 99% of work is building on things, and replacing all of your code is infeasible. But there are a lot of re-architecture projects going on right now where people are building microservices. They're doing new things in new ways, and as they do so, building in Go, building in Rust, so that at the language level you're safer, and then using modern frameworks. These eliminate so many problems. I mean, the reason people hate static analysis is not static analysis. It's C pointers. It's what?
For me, it's the output.
No, it's not. That's not the reason. That's the effect. The reason is because C pointers make doing proper static analysis impossible.
Tell me more about it.
Well, when you are doing things like pointer arithmetic so that the control flow of your program is influenced by the data that comes in, right? And let's just say something simple. We take a bunch of input from the user, we calculate its length, and then we do something that jumps to a location, which is the length of the data plus some amount. The static analyzer can't predict where that jump is going to fall.
No, because it's input driven.
And so doing static analysis on your C code becomes really, really complicated because of things like this.
Right? But you have dynamic analysis though.
You do, but dynamic analysis is incomplete. But when you're doing static analysis on something like Java or Go or Rust, it's much more tractable. And the academics have a bunch of language around this. But we don't hate static analysis for what static analysis is. We hate static analysis because it can't process some of the things that the C language exposes. And, when I read Robert Secord's book on writing safe code in C and C++, you know what my takeaway was?
No. What was
I
it?
No human being can possibly write code in C or C++ and have it be safe.
I can't agree more. Despite my love for C, it's I wrote in C and assembly as my first language. Actually, no, I think it was Pascal. Pascal was my first language. C and assembly was my second and third language, and I love that, and I love it. But I agree with you. You have to specify so many things in C, despite the use of the library.
Hey, Francesco here. A very quick message from our sponsor and then we return back.
This podcast is brought to you by the generosity of NSC42 Ltd, your cybersecurity partner. Cybersecurity is complex and different for every organization, and you need the best tailored service to make sure your customers' data is safe and sound so you can focus on what's important, focusing on your clients and bringing the best and safest experience. NSC42 Ltd can help you during your cloud transformation, cybersecurity assessment for your compliance checklist on-premise and on the cloud. Want to know more? Visit www.nsc42.co.uk to get your free quote.
Yeah, we're saying about there is so much to write on C. And despite the use of the library, I mean, it's all up to you, and you make mistakes. The good part of Java is that it provides you a framework. The higher you go, the more you rely on the framework that you're building on.
Mm-hmm.
It could cause a devastating effect, because if you have a problem in the framework, everybody gets affected.
But yes, but
it's much more rare.
It's much more rare, and someone else is going to help you fix that code. And to me, this is actually where threat modeling starts to shine, is as we develop better languages, as we learn to write better frameworks, as we learn to write interfaces, APIs that are comprehensible, right? You look back to stir ncat with the off by one errors introduced by you have to calculate lengths of your buffers as you're putting things in there and remember to include a space for the null terminator. Huh?
What could go wrong in there?
Yeah.
I wonder.
But as we stop asking people to keep all of these insane details in their heads, what remains are the logic issues. And this is where threat modeling really starts to come into high value, is we move away from, did you remember to include the extra byte for stir ncopy in all your code, to how is this going to come under attack? What can go wrong here? And really asking human beings to do the work that only human beings can do.
You, and I think that's the the undertake of threat modeling. So we were really good, if you want, with Waterfall and other stuff, at thinking strategically, long term, architecturally, but we were too slow. And I'm going to say something that can be blasphemy, but with the DevOps revolution, we just push on the accelerator like insane. And the world has gone at 200 miles per hour, forgetting that strategy, threat modeling, and those things do still count. So wise organizations have done a mix, though.
I think that the DevOps revolution is fantastic. Doing small increments of work, shipping quickly, learning from it is phenomenal. And I think the idea that you have to give up strategy in order to be in a DevOps world, the idea that you have to give up threat modeling to be in a DevOps world, the idea that you even have to give up architecture to be in a DevOps world, I don't believe any of these, right? I think you can be strategic. I think you can architect your systems. I think you can threat model. I think you can throw all of these away and say, we look forward to failing quickly. No, I never look forward to failing. I acknowledge I'm gonna fail. I acknowledge I'm gonna make mistakes, but I can have a vision for how my components come together. And in having that vision, I can fail less. And it's inexpensive to say, we have this whiteboard level understanding of what we're doing that helps us all run in the same direction at high speed.
Thank you.
Because if you don't, right, if you don't know where you're going, if you don't have a rough plan, right, you just put people, you watch kids playing soccer, football for your European audience.
Yes.
Right.
And hope that they go in the right direction out of common
all
sense.
All of them run towards the ball at all times, and you end up with this scrum of people right around the ball and nowhere to pass to, nowhere to really advance the ball upfield because you've got a bunch of kids. And then you watch professionals playing, and there's maybe 2 around the ball, maybe 3, but everyone else is spread out across the whole field because they have a strategy. It doesn't mean they're not working hard.
They're working smart.
Yeah.
They're working all together to accomplish one objective. They're not paddling in all possible directions, working like crazy and hoping that. But
paddling in all directions. I love it. Keep going.
And that's the difference between, and that's exactly the description that I say with DevOps when they criticize and say, well, we come up with strategy and solution. And I say, would you start paddling in all direction and stay still and maybe move wiggly in some direction, or say, I want to reach there and we all paddle in that direction. Each one does its own thing.
Mm-hmm.
But they're all striving for a same point. They all have a common objective. And you can only achieve that. It doesn't take an enormous amount of time, but you only achieve that if you take the time to think strategically. And I always say there is a time and place for strategic thinking and for going fast. So as long as you dedicate, or what do you think?
Yeah, I love what you have to say here. It doesn't take a lot of time to get everyone to paddle in the same direction. And paddling in the same direction gets you where you're going way, way sooner. So, there's a experience of throwing out the baby with the bathwater. And I think that a lot of modern technology practice involves saying we're going to reinvent everything because we can. No, you don't need to reinvent everything. You need to reinvent the things that are not working for you. And sometimes doing something like replacing your waterfall with Agile requires throwing out a lot. But if, for example, your meetings aren't working for you, there's a lot that's been written on having effective meetings, agendas, minutes. Keep it short, keep it on the agenda, know if this is a decision meeting or a discussion meeting, know who's making the decision. This sort of thing results in way more effective meetings. You don't have to reinvent it all.
Giving time to people to actually think about the meeting and summarize the meeting instead of doing back-to-back meeting.
Yeah. And so similarly, when people say, we're going to get rid of our waterfall, great. But don't think you have to invent everything new in order to do that. And do some retrospectives, right? Retrospectives are a crucial part of the Agile approach. And if you never and people hate doing retrospectives, they're uncomfortable. But if you discover, hey, all of the code that Adam wrote in the last 3 sprints just got thrown away because it didn't fit with the code that Tanya was writing.
It makes
Maybe
sense.
we should spend 5 minutes talking about how Adam's code and Tanya's code are going to fit together rather than writing it all and tossing
Yes.
away weeks of work.
And that's a good learning. Also, in AppSec, one of the good things that we did was retrospective of code and what we fixed and start documenting those things. And I know that sometimes in DevOps, there is this misconception that let's just do stuff and document very, very little. And I disagree with that. Let's document the minimum amount. So, for example, we were documenting how we were fixing chunk of code with which library, with which methodology. And we created this fantastic library of quick fix that were absolutely adapted to the organization, not generic quick fix that you can find. And it was absolutely critical because people were starting to go there and say, I could fix this in this way, documenting the knowledge and the understanding.
So I hate documentation. And I think of documentation as another deliverable. And the thing that I like to do to make documentation useful is I like to think about who is the customer for this documentation, right? Is it my future engineering team? Is it my regulator? So I'm doing a lot of work these days with medical device companies. And when you build a medical device, there's a device record. And the device record encapsulates the engineering decisions you made along the way to building the medical device. Now, if I'm working with a team that's shipping a mobile app for, I don't know, food delivery, I've literally told them, take photographs of the whiteboard, take photographs of the back of the envelope, file some bugs, you're done threat modeling. Yeah. That's not what I tell a medical device company.
No, the screen will be rather disappointed, I guess.
But we can think about documentation in terms of customers and
serve a purpose.
Yes, devote appropriate attention to the documentation.
I agree, and it's the critical thinking that sometimes is missing when you're pedaling too quickly, and that taking 5, thinking rationally what makes sense, not just going as fast as you can. I'm seeing a lot of transformation that is DevOps is taken as a sledgehammer to the organization. Organization really old, especially in the financial world, where DevOps is taken as a sledgehammer. Let's destroy the status quo. Let's do something completely different. And that's fine at the beginning, but it tends to drag along too long, and it becomes a habit. And that's where I have the danger. And
so I think a lot of this goes to people's satisfaction in doing the work. That the thing I love about DevOps is the speed and agility that it gets us. People are happier being able to see their work completed, being able to check something off and call it done. And I think what happens in a lot of transformation projects and a lot of the threat modeling work I do, I really position as change work, that we're changing the way the organization does things. And so making sure that we have a sense of urgency, we're removing barriers to success, that if we believe we're going to do it by rolling out a document that says you will threat model or you will agile, and not give people the mission, the coalition, all of these things that make change happen effectively, it fails.
I agree. I can't agree more. And the vision and the why that motivate people. But also, I love what you just said on small goal and the fulfillment that gives. And that, I think, one of the powerful elements of DevOps, to see your work accomplished and to see small goal, well, it's like small step towards a goal, ticking the box. It generates endorphin. It's satisfying. It makes your work worthwhile instead of just saying, well, I've worked on a piece of code for 9 months. Let's test it. and everything fails, and let's go back to the whiteboard. And what did I eat for breakfast, and why am I still living, and things like that, right?
And one of the things that I'd love to address, and actually let me just comment here. Since I've mentioned threat modeling repeatedly, let me give a 2-second intro to threat modeling. Threat modeling at its heart is 4 questions. What are we working on? What can go wrong? What are we going to do about it? Did we do a good job? And oftentimes people have this perception that threat modeling is a waterfall activity, that the output of all of this is big threat model docs, it's complex Visio diagrams. It's not. I can ask this question about tiny changes. What does this tiny change entail? What can go wrong with this tiny change that I'm making in this 2-week sprint? And so doing this, going up to we're living in a pandemic for a while now, but in a stand-up meeting where you plan the next sprint and saying, hey, my change here is I'm changing the CSS for the mobile app to enable better alignment with our brand standards. Okay, I don't see any security problem with that. Great, you go ahead. Somebody else might say, I'm adding compliance with the open banking API standards. I'm going to spend the next 2 weeks doing a security analysis of these 4 standards that allow people to get balances, recent transactions, whatever else is in the API set. But because this is going to open this up, I'm going to do this extensive security analysis before implementing it. Both of these are threat modeling work, right? We asked, what are we working on? The answers are very different and result in very different ways of answering what can go wrong.
Yeah.
And so this 2 minutes of strategy exposes these new APIs are really meaningful from a security perspective. We have to make sure we get it right. And getting it right is not just a matter of secure implementation. It's got GDPR implications. It's got Financial Services Authority implications. And so rather than write the code and then, we're going to ship it 2 weeks from now on Friday, on Thursday, I'll call our FSA interface people and ask them if they can do a code review for a ship on Friday.
They probably wouldn't be very happy about it.
But they will be unhappy with it. And we can either engage in the old school finger pointing, very in my way, escalation, fight. Everyone goes home angry and yells at their kids. Or we can plan the work a little bit. We can say, yep, this one is complicated. Let's make sure we talk to the people who are relevant so we understand all of our requirements up front. Which of these results in happier developers? Which of these results in happier customers?
I think a little bit of strategy, but also require a little bit of hindsight. But I love what you just said about threat modeling, and I wouldn't even call it strategy. I would call it just threat modeling, sensible threat modeling, where you think about what could go wrong, what's the impact. That is fundamentally a risk assessment. And developer do it. And if I change this component, what could I break? Hopefully, if they're used developer to a specific framework and they're changing a specific line of code or component, what could go wrong? How much damage could I cause? And then they decide, do I touch it? Do I don't touch it? And bringing the security lens is just a little bit of education. So why still so frictionful doing threat modeling inside team? In your opinion, you've been doing threat modeling with team forever now.
So I think one of the problems is that threat modeling is actually in the same way that software development has all sorts of aspects to it, right? We can talk about the language, we can talk about the methodology, we can talk about our test suites, we can talk about Agile and Waterfall, we can talk about which editor you prefer, let's not. Threat modeling has all sorts of aspects as well. And in doing threat modeling, we can talk about the technical skills, things like stride or kill chains or abuse cases. We can talk about the organizational aspects. And the folks over at F-Secure just did a great blog post on integrating threat modeling into SAFE. And it's all about the organizational aspects of doing this. Where does it plug into epic planning and feature refinement? It has nothing to do with stride or kill chain or any of these other bits of threat modeling. And so one of the pieces that makes threat modeling complicated is that we have so many pieces. And I just released a white paper, which I call the Jenga view of threat modeling. And to build our Jenga tower, we have technical skills, we have soft skills, and we have organizational discipline. And each one has a cost. You have a training cost, you have a bureaucracy cost. And so what we want is a Jenga tower that is both inexpensive and stable. And so there's this trade-off to building the tower. And I think the reason people get confused about threat modeling is they're not sure how many blocks they need. They're not sure what sort of blocks they need. And they look at this and say, I'm just going to go read, heck, I'll point at myself. I'm going to go read Adam's book, which is full of building blocks. And I'm going to assemble up a set of building blocks, and I'm going to believe that those are the right building blocks. I'm not going to ask, did we do a good job? I'm not going to check how well we're doing, and I'm just going to keep doing this. When people get started, I tell them that they should spend as much time on retrospectives as they do doing the technical work. Ask what worked, what didn't, what do we keep, what do we change? That ratio falls off very quickly.
Yeah.
But giving space for the conversation is huge.
No, I like the idea of the retrospective and giving, and I love your Jenga. But before we close off, actually, Adam, first of all, I thank you for coming, and I thank everybody for listening to this application security rambling. But can you leave us with a very positive message? You left Crumble a positive message, but your positive message to the industry before we close off.
So my positive message is this. When I got started in this industry, there were so many problems that we couldn't even define, never mind manage. And over time, we have learned so much. We have developed so much discipline around managing some of the problems like vulnerabilities. We have gotten more mature about how we authenticate. We have understood that the technical problems require attention. We are making so much progress, which is invisible against the noise. Take the long view. Remember that we've conquered buffer overflows, which I never would have thought possible. We are learning to threat model. We are learning to... I'll tell you a quick story. I remember 1993, 1994, the folks at the San Diego Supercomputer Center found a core dump on a hard drive.
Mm-hmm.
Where once they disassembled the core dump, they found that someone had actually exploited a stack smashing overflow against some RPC daemon. They called their vendor. It took 2 years for that 0-day to get fixed, when it had been discovered by actual forensics on a live system. That sort of thing was commonplace at the time and rare today. Yep, there's still problems with 0 days, but not from major vendors in the same sort of way. The idea that it would take 2 years to add a length check to this it would be inconceivable to happen today. We're making progress, we're getting better. And if you look across a longer view, you have an opportunity to see it. So please do.
So take the time and perceive how well and how far we've gone, so it's not doom and gloom despite COVID.
Indeed.
Thank you so much, Adam, and thank everybody for listening. I'm going to have you again coming in, and we're going to go in another rabbit hole, but hopefully a little bit more on threat modeling this time.
Thank you all for listening. I hope the audience enjoyed it, and I look forward to doing it again.
Thank you, Adam. Have a great day.
Thank you. You too.
We hope you enjoyed today's episode. If you did, consider leaving us a review or sponsoring us on Patreon. It helps us bring on amazing guests and keep the podcast alive and free. Consider supporting us at www.patreon.com/CSCP and watch other episodes at www.cybercloudpodcast.com.